Welcome everybody to today's event. Thank you so much for joining us. Today's very exciting, as exciting as always, obviously, but particularly exciting because this is our first event that is sponsored by Snyk. So we're just really pleased to be able to do events like this, and I'm really excited to hear what Brian's got to say to us as well. So for those of you who don't know me, let me introduce myself. My name is Abby and I work with Barry Cranford, who's the founder of the LJC, and I have the privilege of hosting today's event. The LJC is just one of the communities that is run by RecWorks. We are a tech recruitment company with a massive difference. As a company, we believe that recruitment really can be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development. From our perspective, if people want to learn and others want to teach or share knowledge, we are more than happy to connect you through our communities and our events like this one. We see this as giving back to those we've worked with in the past, but also paying it forward to those we hope to work with in the future. We've run over 700 events to date for engineers and developers, students, graduates, CTOs. We have run conferences, lightning talks, hackathons, member mingles, all sorts. In January this year, we made our 4,000th introduction through our Meet a Mentor program. And again, we're really excited to see where that's going to go next. As I've already said, we love to give opportunities for people to connect, and this event is part of that. If you would like to know more about any of our communities, please do get in touch with myself or Barry or Helen, and we can take it from there. I'll just note, not Helen Scott, Helen Lewis, for those of you who I might have confused just then. Just to let you know as well, today's session will be recorded and you will be able to find it on YouTube if you search for RecWorks, but also I will put my LinkedIn profile in the chat so that you can just ping me and I'll be able to send it on to you as well if you want it. With no further ado, I'm going to hand over to Brian for our talk about stranger danger. Over to you, Brian.
Thank you. And then always, this is the hard part, sharing your screen, and it works. That is amazing. Anyway, let me try to get the chat up as well, if I can do that on my other screen. 1 second. No, that does not work. Anyway, feel free to open your camera if you want to. It's always nice to look at face instead of a void. But if you're not comfortable, feel free to close this. Well, I am happy with both. I have the chat room open in the meantime, and I know the LJC is the London Java community, but nowadays we're all fully remote. I am based in Breda, which is basically an hour south of Amsterdam. Where are you based? Please put that in the chat because I want to know where you're from, who I'm talking to, because what Abby already said, this is about connecting, not just me giving a presentation. I want to know where you're from, who I'm talking to, because that is what I love about the community, and the Java community already is great, and let's make it even bigger. But today I'm going to talk about stranger danger and your Java attack servers just got bigger. And that sounds really, really scary, but it is not. It's just a matter of how you think and how you look at things. But first, before we go into the actual attack service, I need to talk to you about this word, DevSecOps. And if you have been on that security hype train for the last, say, 2-3 years, you have heard this word like too many times. The first time I saw this word, felt to me like yet another buzzword. Let's put it next to machine learning and blockchain, and then we have the full buzzword bingo card. However, if we look at this more closely, we see it's an evaluation of DevOps. And DevOps is something that we all try to embrace. Who of you thinks they're doing DevOps? Just put a 1 in or a yes or whatever in the chat. Who practices DevOps? And put an N or a no in if you're not, or nothing. Well, the thing with DevOps is struggling with it. I struggle with it. I can imagine. One of the things is that look at what DevOps actually means. With DevOps, we try to tear down the wall between the old-fashioned developer organization and the operation organization. These used to be separate things, right? We build something, it works on my machine, throw it over the wall, and then it's your problem. That is how we used to work. But with DevOps, we try to tear down that wall, get these teams together, basically as a new team where both the knowledge of developers and active operations folks are in that same team. And as a team, you should be responsible for the whole thing. And that's what it is. We're creating stuff, and all the way towards production, we are responsible for it. It's not, I create it, now you do your trick. As a team, we're responsible for it. So it means that if something goes into production and something goes wrong, they come back to the team. Basically, eat your own dog food. Make sure that what you create is worth it, is good, handle it. And if you make a mistake, you have to handle it some other time, but still. However, DevOps, we focus on functionality, on features. Look at your Scrum board or Kanban board or whatever you're using. You probably find a ticket on there that says, I, as a product manager, want that if I click X, it does Y, or that my customer can do. These are all features, feature-based developments, what we do. But nowadays, we also know that we need to scale. We need to be scalable. We need to be maintainable. It's not a thing anymore that I can handle 3 requests per minute. I need to handle 3,000 requests or 3 million requests per minute, which is a whole different mindset, but it's not captured in such a functional requirement. Security is one of them, but that is still not in the mindset of either the developers nor the operations folks, because we're not thinking of it. And we should. From the get-go, we should be handling security just as much as we do with scalability, maintainability, readability, or all the abilities we nowadays think are good or applicable to clean and good code. So this is me. I'm Brian. I'm a developer advocate at Snyk. I work in the Java community for about 15 to 20 years almost. 17 years, it's COVID time, 17 years-ish. Let's say that, maybe 17.3, I don't know. Anyway, don't get you up with the details. I'm a Java champion, do some stuff in mostly the Java community for the Netherlands, so the NLJUG, but also working with a few other folks as a JUG leader for the Virtual JUG and doing some other stuff. But that's not important. We're talking about security here. And with a DevSecOps, we're trying to solve a problem. Well, first of all, let me take you to my own personal journey. And that was, well, say 15-ish years ago when I started to be a full-time Java developer. I worked for one of the government agencies here in the Netherlands. And what we did is we released our software 3 times a year. Can you imagine? 3 times a year, we just had a release point. Then we created a release agent and we put it over to the ops team, and they made sure that it went to production, which means we had a ton of time to test it, to make sure that everything was safe, secure. Not that it was, but we could do a lot of things, and we took the time for that. But nowadays, the world is different. Let's look at e-commerce, for instance. I worked at a company before I worked at Snyk, which is basically the equivalent of some sort of Amazon. And at that point, the service my team was responsible for, I was a team lead there. We sometimes deployed 3 to 4 times a day. And that is a whole different ballgame. You cannot do a full pen test if you release 3 times a day. It's not possible anymore. But we still need to do that because we need to deliver that feature before our competitors. Makes sense, because at that point you have an advantage, tra-la-la-la, you make money. That's in the end what you do. But the point here is, security is not yet on the focus of the development nor the operations teams. Through that life cycle, there's nothing that we might think of security in an essential way, like maybe I shouldn't put that token in as plain text. Fair point. But how much do you think about security when you're building? Probably not so much. And we see that security is still a siloed expertise at the end of your development lifecycle. There is one security team serving a ton of engineering teams. And probably the engineering teams are growing, are scaling because your product scales, or you need to do more, or you split it up into micro or nano services or whatever is cool nowadays. However, the security team is still one team serving them all, which means if we need to help the security team out, because in the end, we're still at the same team. We don't want our customer data to get compromised. So we need to play along with each other. We need to get out of our cubicle and look around and see what the other folks need to accomplish, because in the end, we're one team. So how bad is that situation? Well, let's nowadays think of development. If I as a developer think of software development, the first thing I think about is my code that I wrote, and it's nowadays on GitHub. But that is what we call the tip of the iceberg. It's about 10 to 20% of the code we actually put into production. And I will come to that later. It's very important code because this code makes the difference. This code is basically the business logic that makes your application specifically for that particular problem, or specifically eligible for that company you write it for. However, say I create a Spring Boot application and I make an endpoint. Very simple nowadays, something like this. I have a controller and it maps to /hello, and I already made a security issue here. I created a security problem already in my 7 lines of code. You might be able to see this with things like code reviews, but think about it. How are you doing code reviews? Is that about, no, that curly brace is on the wrong line? Or are you actually looking at issues? Don't answer that, please. I don't want to know, but think about it and look from that perspective to what's going on here. Because the point here is that one of the request parameters is a username or a string. And without doing any form of sanitization, I put that user back into the response writer. You should never do that. I don't know what the user is. So that can be anything. Basically, I created my first cross-site scripting issue. It's not my first Sony, but something similar. Because if I do this, if my user is a script like this, it will just trigger an alert. And an alert is nothing wrong with it, actually. But if I can call scripts like this, I can also go into your cookies, your session IDs, and these might be valuable to me if I can steal them and pump them over to another system. Something you don't want. And these ones are easily fetchable. By the way, cross-site scripting doesn't only need to be a script like that I showed you, but it can also be an image source or mouse over. These kind of things can be triggered to basically call on scripting on the machine of the end user. So let's go into an actual application, because that's far more fun than doing this on a slide deck. Of course, my password over here is admin, because why not? I work at a security company. Oh, it's not even. Yes, it is. No, don't. Yeah, check password, I know. No, don't save it. Please don't. But I will show you the issue here. So if I search here, and this is the issue. What you see in the top, and I will enlarge it a bit for you, you see that my parameter is Batman, and Batman is also the one that is printed out here. So if I do something like this, script alert 1, then we see that there is an alert. So I can do all sorts of stuff, not something we want. Well, let's go and figure out what's going on more in this application. I wrote something and I can search here, like it says I can use the % as a wildcard. Cool. So I can do this and I can submit and it gets Spider-Man. But what do you think can go wrong with this? This is already a hint to me, because the % is also the wildcard for actual SQL. So this might be able that I can do a Sql injection here. Let's do something fun. Let's do this. Say it is an actual Sql injection. With this semicolon, I break off or I end the actual query and I just start a new query. Update all users and set first name to muhahaha, because that sounds evil. So if I submit, I won't get anything back. But if I search again, you see that every first name is muhaha. Maybe you caught this in a unit test, maybe not, but that is up to you. Like, it's not only functional anymore. Like, these are weird edge cases. And well, let's dive into some code. Say for instance, I'm having here a plugin in IntelliJ, and this is the Snyk plugin, and I'm using this to catch these kind of vulnerabilities while I'm coding. So I already did some scanning over here, and you see it found a cross-site scripting issue. It's based on user controller 35 to 38. Let's go to 38. It jumps to there, And basically, this is the first example, more or less the first example I showed you. The parameter over here is printed out over here without doing any sanitization. Let me enlarge it a little bit so you be easy to see. One of the suggestions to fix this is, hey, maybe I can use the string escape utils from, I think it's from Apache Commons, which is a reasonable thing. But again, this one is quite easy to catch if you do proper code reviews. Same with the Sql injection. Sql injection is also something that says, oh, this is the mapping, and it probably is somewhere in, it starts in user controller, ends in search repo. Cool, let's go there. Let's go to my search repo. And yes, what I did is the parameter here is string concatenation on my SQL query. And obviously I should use, for instance, a prepared statement. Or you can use the Spring libraries to do it. There's a difference because prepared statement does it in 2 steps. Prepared statement already sends the query over to the database if it is possible in your language. In Java, it is. The prepared statement is sent over. The database already creates the execution order, and then in a second step, you put in the parameter. If you do a proper prepared statement, that means that because the execution path is already created, a SQL injection is not so much possible anymore. However, you can also use the Spring CRUD repositories to do this for you. They do sanitization on the client side, so in your Java application, and send the actual query over to the database. So it's not a prepared statement, but still, it's much safer than do it like this. You get me? Anyway, again, this is probably something you could have found as well with proper code reviews. But wouldn't it be nice to have this already while I'm coding? But what do you think about this one? Line 69, a path reversal. Well, I will enlarge this code for you. What it does is I'm trying to save a file, a multipart file, but I'm saving it over here. I'm taking the upload folder, which is a static variable, and I say, let's get the file.get original file name. But think about it. The multipart file object is just a representation of your post request. If I'm able to alter my post request in such a way that I can make this name a little bit weird, something like ... whatever, then I might be able to, instead of putting this file into the upload folder, traverse out of it, go all the way to, for instance, the root, and put it somewhere I don't want it to be. Of course, this depends on what kind of user you run your application with, definitely. But most security problems are not a direct hit, are multiple problems connected together that make your application go boom. So definitely this is something that I didn't think of. And it is nice that my tooling already says, like, hey, you might want to do something like look at the canonical path. And let's see if one of the options tells me that. Over here, it says, let's look at the canonical destination, get canonical path. So actually, what does that ... traverse to? What is the canonical path? And does it actually start with, for instance, the upload folder that I want it to be? Which makes me think of software development and creation and saving files in a totally different way than I was used to when I was just a average Joe developer and not into security at all. All right, enough examples. We talked about code, and code was just at 10% or 20%, depending on how big your application was. Say under the hood, so under the surface of that iceberg, under the waterline, there is the 80 to 90% of the rest, and that's basically all your frameworks and libraries that you pull in. Just take a look at your POM file or your Gradle file and see what you pull in. Do you actually got an idea what you pull in? Because frameworks pull in libraries, pulling in libraries, and it goes several layers deeper. You have no clue anymore. I don't have any clue. Well, that can be a problem if you're depending on a library and it was like, hey, it still works, let's not update it. Because if it works, don't touch it anymore. You probably know that. 2017, take you back to an ancient history, pre-COVID. In March 7, 2017, there was a problem with the Apache Struts library. There was a problem found, but it was already patched. in March 7. However, a company called Equifax, based in the United States in Atlanta, Georgia, they do crediting scores, which is a pretty big thing for the Americans, apparently. They were breached in May, so that means 2 months later, because they were running an outdated version of Apache Struts 2. It was possible to do a remote code execution there, and they didn't know, because probably they didn't focus on what was already in production, but more on the new features. Feature development, feature-wise development, what I was talking about in the beginning. So people were in there for over 75 days, snooped around, and in the end, over 140 million US customers were compromised. At this point, over $2 billion of damage, and we're not counting in any damage it does to the branding. To be fair, if you work nowadays at Equifax, you probably have the best security team in the world, because seriously, they did a great job of their postmortem after this was amazing, but it just shows you that they were depending on Apache Struts 2 and a vulnerable version of Apache Struts 2. So let's do this. Let's show you what this problem actually is. I have an application over here. This application runs on Heroku. It is actually in the cloud, so I just tried to spin it up because I already had it up like 50 minutes before this webinar, and it might have been spun down. Anyway, hopefully this works, but let's go into the terminal because, hey, no hacker will do this from the browser, trust me. Anyway, what I'm going to do is this, and let me enlarge this so you can actually read what's happening. Because I have Apache Struts 2 in this application, I don't have to touch the application at all. I can make a curl request using a specific header to do a remote code execution. And this is the header. It's a content type. So you see the key content type, and this is the value of that content type. And you might recognize it because it's an invalid content type. It's not a real content type. It doesn't exist. And there is exactly where it goes wrong. Because this specific version of Apache Struts allowed you, when you have an invalid content type, you go into an exceptional flow. And for some reason, we were allowed to utilize OGNL, which is Object Graph Navigational Language, or well, expression language within Apache Struts. And with that expression language, I could call certain methods on objects or create new objects. And that is exactly what I'm doing here. Let me enlarge a little bit more so it goes on one line. I am creating a new process builder. And that process builder, I feed it the bash. And the bash, I can feed an arbitrary command. And then I get the output stream rerouted to an input stream to just show it on the screen. That is interesting. So let's hope this one is up. It is. Cool. So let's do this. And let's use this one. I will just explain to you in 1 second what I'm doing. So what I'm doing here, I'm using that header I showed you, and I make a substitution. I get the word command out, and I get the word env in. And env is nothing more than the Linux command to get you the environment variables of your system. And I basically do a curl -v-x get to not to localhost. This one is not on localhost. This one is real. This one is on Heroku. So let's remove this one.
It looks like I no longer have access to one of your calendar accounts because your login has expired.
Oh, that's cool. Sorry, Alexa.
By visiting calendar settings in your Alexa app.
Maybe I should mute her first next time. Anyway, just put this on Heroku, and let's see. Oh, what am I doing here? Yes. Now let's see if this works. And what you see here, because I reroute the output stream to an input stream, I basically get at least partially the environment variables on my Heroku machine. And this is interesting because the environment variables are not that special. But if I can call this, I might be able to call other things as well. Maybe I can create a file. Maybe I can create a file with some content, basically a script. Come back tomorrow and execute that script. Good luck with your postmortem finding out what the hell happened in the end. It is quite a big problem if you can do remote code executions. And now I know, for instance, where the Java options are and where the Java home is. Not so much a problem again, but if I can call this, I can do much worse things. But I won't, because I want to use this demo for later. I need this demo for later. Anyway, let's get back to this one. So if this is your application, this is the binary, your jar or your var, or maybe even an old-fashioned air file that you put into production. This is probably the code you've written. The rest is either Apache Struts, Spring Boot, well, what flavors do we have more? Micronaut, Quarkus, whatever, and they pull in a lot of other underlying libraries. So we did a small experiment some time ago, demo application with 222 lines of Spring serverless code, very bad code. It was for a demo, a lot of duplications. I wrote it, don't blame me. It was for, again, it was a demo, but for the numbers, it had 5 direct dependencies. And these dependencies pull in dependencies, and pulling in dependencies like several layers deep ends up in 54 dependencies in total. Now the question, my team is handling this, and we're not responsible for the 222 lines of code, but how many lines of code are we actually responsible for? Pick a number in your head, put it in the chat, doesn't matter. I will give it you in a few seconds. Just think about it. Guess. Trust me, it's a lot. It is about 460,000 something. This means that, and think about it, every class that is available on the class path in Java can be loaded technically into memory. So it's not like, yeah, but that code isn't reachable. Well, depends on what you have in it. Maybe I can do a remote code execution, lift something up and connect the dots of multiple problems together to make it an even bigger problem. But all the parts that are in are technically available to you and can be loaded into memory and might be able to and an attacker might be able to use it in an attack chain. So it's not the 222 lines. We have to take as much pride as we do in our own code to and show that same dedication to the things that we inherit, that we depend on, because users or people are using open source and a lot, and that's a good thing because the open source world is nice and people are helping each other. But it's also a point where attackers come in. They look at that, and if there is a problem in a library that is well used, I have a potential pool of victims that is large. And think about it, Equifax wasn't the one that was targeted. No, they were just in the middle of the crossfire, just firing off requests to every endpoint on the internet, probably with a script, because manually that's a lot of work. And they just found out that some applications were vulnerable. And then you go into deep, that's your next step. So new packages are coming in every day in every ecosystem, and NPM is the clear winner if you look at the most commonly used ecosystems. They are post that I think already that 2 million mark already, but that is because NPM packages are small and Java packages are more larger, as in we inherit frameworks nowadays. It's not just a single package, more or less. You probably depend on not just a single package, but for instance, a BOM file instead of just a single POM, if I'm talking in Maven language. But every year new vulnerabilities get found. The point is that it's not so much what you pull in, but what is underneath. So where were all of you, say, specifically December 10th, 2021? And that, I know that's very specific because that was my first day of my vacation. And then all hell broke loose because this happened. If you haven't heard of it, type in log4j or log4shell, and you probably found out there are a trillion articles nowadays. What happened was there was a vulnerability in a famous log library, log4j. Not going into that, but it had a lot of impact. And most people had that library as a transitive dependency. So not so much directly, but because they were using a framework, or they configured their framework in such a way that they wanted to use log4j too. And we saw in our data at Snyk, we saw that we have 57%, almost 60% of the folks had log4j as a transitive dependency at that point in time. And every library, every version at the initial point, December 10th, was vulnerable. That means that roughly they looked at Maven Central, over 17,000 Java packages were impacted because of this. And in the first 72 hours, there were companies that tried to measure the amount of attacks, not say that every attack was actually working, but the amount of attacks was about 800,000 attacks in the first 72 hours. Most of them were automated. Let me briefly go into the hack and explain to you what happens if you don't know. Say you're using Log4j in your application and you're logging something. What would be an easy thing to log is, say I want to log in with the username and the password, and the password is wrong. You probably log at that point, username Brian, failed attempt, something like that. But I know my username is logged. Cool. Now you see over here, there is this JNDI string here. So with this JNDI string, I can do a lot of harm, because apparently in Log4j since 2013 or something, you can do JNDI lookups. And I combine this with the LDAP protocol. So what I'm saying is, let's go to the LDAP server to do a lookup to evil.com port 9999/evil. I own this, or the JNDI is here. I own this LDAP server. In this case, what I can do is I return a reference to a class that I also host, for instance, on an HTTP server. And because it's a lookup, you will get the class. And because of some default values, this class will be, well, there will be an instance of that class. The class will be accepted. And because that class is accepted, when an instance is made, I can do a remote code execution. For instance, if my evil class looks like this. In this case, I implement the object factory and I say get object instance. I know this will get called. So when I instance this evil class, and I know it will get called, this get object instance would get called as well. And eventually, you see over here that I am runtime.get runtime, and I'm basically saying here, open my calculator. Let me show you, just easier. But you have now a clue what the logistics are behind this. So I have this same application again, and of course we build in the same problem. So let me log out and let me put over here. So what we see, I'm using a older Java version. Now let me show you what version. Here. Over here you see I'm using 1.8.0 build 111, like build 111 of Java 8. I've got my LDAP running, and that's HTTP server. So what I can do is, if I do something like this, my name is Brian and my password is something wrong, and I sign in, I know that from the logs, let me check if that's working, failed attempt for username Brian. Cool. So now I can do the same thing. So saying, I'm going to my local host on port 9999/evil, and the password doesn't matter because the username is the one that gets printed out. And if I sign in, hey, my calculator spins up because I exactly have that open calculator in my evil.class. Okay, fun. This is interesting if you want to calculate something, but not really, to be fair. And well, I read someplace that it's not always the case, because there's actually what we wrote as well. In the first few hours, it looked like if you had the new Java version, it wasn't that bad, because in the older Java versions, like 111, this trust URL code base parameter was by default set to true, which basically means like I trust that code and you can just import it. Newer Java versions, Java 8, version 191 and up, and newer versions of Java 11 and Java 17 didn't have that default setting, but had that default setting set to false. So they probably are not vulnerable to that thing anymore. However, you are, but differently. So I now need to spin the things up, but this is a first timer. So hey, hope it works. Always nice to do some freestyling here. So let me spin up a Docker container. And hopefully this works. And or else if it doesn't work, I will just explain you what the issue is. In theory, what the issue is here is, yes, we're not trusting that code, that remote code anymore. However, if you already have classes available in your class path that can create a so-called gadget chain, That means that a gadget is something that if you deserialize it, you can trigger an action, for instance, a remote code execution. I'm still able to do these kind of things. So one thing, I spun this up and it probably has somewhere the Java version in here, hopefully. Yeah, here. So Java version 3.20 to 3.22, one of the latest ones. So if I do the same thing over here, and this one now works on, this is a Docker image. So from the Docker image, I want to go back to my local host, of course. That's why I say host.docker.internal, port 9999/evil. Doesn't work anymore. But what does work is the interesting part, that I can do a different thing. I can now look at what libraries you have and use that knowledge to compile a gadget chain that does a remote code execution. Basically, Java deserialization issues, and log4j is your ignition for that. To show you what actually happened, let's go into the code. And in the server, I created something extra. For the second part, I'm trying to do something more hurtful. Instead of just calling the calculator, I'm trying to do something different. I'm trying to execute this string, which basically allows me to do a remote shell access, reversed shell access. So if I listen with netcat to port 9001, for everybody who knows Dragon Ball Z, because it's over 9,000, probably not, doesn't matter. But if I listen to port 9001, I'm able to get a hook over there and have a remote shell, which is interesting. So instead of just doing this via a compiled thing, I'm using the commons collections library, which I know this application has, to use the classes in there, because I know the commons collections library is loaded. This is Apache Commons Collections 3.1, which has a known deserialization chain. And I'm using the transformers here to, again, get the runtime and actually invoke a command. And instead of giving the compiled class back, I'm just giving Java deserialized data back. So what I'm trying to do is using that gadget chain that I know this application has, and don't think like I don't have that library, so I don't have a gadget chain. If you look at all the libraries that you have in your class path, with all the classes available, I bet there is a gadget chain path, or a chain available that can lead to code execution, because Java serialization is an issue. It's hard to find, but that doesn't mean you cannot do it. So my LDAP is still up, and let's listen to netcat. Netcat minus LVP on port 9001, I hopefully said. Cool. So with that, I can go again from my Docker container to my local host and go for that commons thing that I showed you, triggering that reversed shell, doing something like this, signing in. And what you see here is that my listener now has access. So I have access here, so I can see what's in that container. And this container could also be in your AWS cluster or something like that. Or I can say, who am I? Well, technically I'm root, because by default, your Docker container, if you don't specify any user, is root. And you could have prevented this by just updating to the newer log4j library. That's my point. Anyway, I thought it was fun to show you that even newer Java versions were vulnerable. It's a bit more complicated, but it doesn't mean that if you have a newer Java version, you're not vulnerable. Okay, let's continue. Let me just spin down this Docker container, because my machine currently sounds like an airplane trying to take off. It blows air to me like a madman. Anyway, how do you find out about these vulnerabilities? A lot of people, unfortunately, don't. But this is the more important question. Who is responsible for security? It's a shared responsibility between developers, the security team, and the operations team, all together. Hence DevSecOps, probably. But if you look at the application, so the software, that means the code and your dependency, so basically the binary you put into production, a lot of people think that developers should take their fair share. And that is reasonable because we make the decisions to solve certain problems, either with implementing a library or doing some custom code. But this custom code should not only perform well and look pretty, it should also be safe. Either the library you pull in or the custom code you write, and preferably both. So we talked about code, open source, and containers. Oh, what? I just want to show you one more thing about an open source problem. You remember that application on Heroku that I had here? Yes, let's sign up for this application. Again, it's on the cloud, and let's sign in. Let's choose password 123456 because I work at a security company. No, please don't store this. What I can do is in this application, I can create to-dos, and I can do something funny like eat pie, use the pie sign, give it a date somewhere in 1970, and well, I'm probably hungry by now. So I create this, and you see that the pie sign is now transformed into a symbol, basically the ASCII representation. Okay, good to know. Well, think about it. We have a function in the JDK native to ASCII, which is part of the JDK. Hold that thought. You can also upload files, and I can upload zip files. These zip files will get unzipped and will end up in my public folder. But at this time, it's empty. But what if my folder or what my zip file look like this? Oh yeah, remember we also know the Java home of that Heroku instance. So zip info, zip, I think it's zip slip.zip I created. Yes, cool. I'm using this zip file. This zip file contains two files, a good.txt, which is a normal file, and the second one, which is a .. And I already tried to explain to you in the first problem with code that this is a path traverse. We go all the way towards the root of the system, then go to /app/.jdk, which is the JDK of my Heroku application, /bin/native to ASCII, because that's where native to ASCII file is. So if everything works well, I might be able to overwrite this file. Let's try. Choose this file over here. And zip/zip. Cool. So if I upload this file, what we see is that in the public folder, we end up with good.txt. Perfectly fine. So we know unzipping took place. But what happened to the other one? Well, if I create a to-do file, and it doesn't matter what I put in and what kind of data I put in of what the priority is, everything will now be translated to muhahaha, gotcha, because I overrode the native to ASCII file on Heroku. Cool. Why? Because I'm using a library to do unzipping. Unzipping in Java is not straightforward. There is no unzip function in the JDK. So what we normally do is look at the file, inspect the zip entry, get the byte stream out, recreate the file, get the byte stream in, etc., etc. Or we use a library to do that. But this library is outdated and doesn't look at the canonical path, what I already showed you in one of the solutions in IntelliJ earlier. If I would have updated to the newer version, this would all be fine. This would not have happened. So again, updating makes sense. Being aware of these things make sense. And we should do that as developers. Again, we talked about code, open source, but then again, there's more under the surface. For instance, nowadays, it's not just your binary that you pull up. There's also maybe an environment. For instance, a Docker container. We need to run it. We just provide the container containing that application that which you can test and then put into production for some reason. 2019, I did a research on Docker containers and pulled in the 10 most commonly used Docker images from Docker Hub. Because what you do in the Docker file is you start with from Ubuntu or from Debian or from Maven, JDK 3, whatever, base images. You base your stuff on top of a base image that is already available. And all these base images, which were fair base images, real base images, had vulnerabilities. These vulnerabilities were traced back to the operating system layer. For instance, Node.js was built, and this was, I just downloaded the latest version, not a specific tag or a specific hash. This was built on a full-blown Debian operating system. And then makes me think, like, do I actually need a full-blown Debian operating system for my microservice in a Docker container? Probably not. So think about it. What are you using? If I use a specific, maybe an Alpine version of Node or Maven or whatever Java container you want to use, it might already be that there are less binaries with that container. And also, if you don't need it, why do you have it in? Think about it. It might not be directly harmful, but through some other things, we might be able to leverage that capability and use it in an attack chain. Well, we ask people like, do you scan your Docker images for operating system vulnerabilities? A lot of people don't. And also a lot of people don't find out if the container is already in production. And think about it. If you build it with the latest container, so Maven, OpenJDK 8, latest today is different from the latest tomorrow. So that means that even though you don't have to touch your application, you can rebuild your container to get rid of issues that might already be solved in the layer above you, the base image layer, or the operating system layer in that case. So let's do some hacking on this one. I can safely close this. Yes, you can terminate this, so I'm not getting confused anymore. And let's go the other way. Cool. You recognize this application. Same application I had on Heroku, but now I run it in a container on my local machine. The container is already running, but let me show you what the actual Docker file was. So let's enlarge this, and let's go to the Docker file. What I'm doing is I'm using a multi-stage build. I'm starting from Maven 3 JDK 8 Slim, build the application, and then the artifact that is created, I put it in my production container. I create a new container based on Tomcat 8.5.2021. And there's the problem. Tomcat 8.5.21. That's an old one. And I don't even need to touch the application. No, I'm going to attack the Tomcat layer, because Tomcat in this case has an issue. This one. And let me just read it out loud for you. In this version from Tomcat, there was this issue that it was possible to upload the JSP file, Java server page, via specially crafted request. This JSP file could be requested, and any code it contained will be executed. Again, a remote code execution. Love them. ExploitDB. They already created exploits for me. Super handy. So this is a Python script, but the Python script does two steps. The first thing what they do is they try to check. So they insert a JSP file containing only this body. So basically a println with all A's, just to see if it works. If that is okay, we can do the second step and actually create a JSP file that is more interesting, containing a form. And every time I submit the form, I call the runtime and execute whatever you put in that form. So basically, I'm creating a web shell. So these two pages, let me put an enter, do not yet exist. Just to show you that I'm not faking it. I have this Python script already running in a container, of course. So let's do the first one. Let's check if this one is working. And it says it's vulnerable here in yellow. Oh, let me put my, yes. So let's go back. And let's get rid of this thing. So it seems that this one doesn't exist yet. No, but the first one, the POC, all A's now exist. So I know that I can go in through the Tomcat and just put in a JSP file. Well, let's do the second one. Uploading web shell. Interesting. So if I go here, I now, without touching the application, but touching the container, I now have a JSP file that basically gives me root capabilities because, again, you saw my Docker container. I'm not specifying a specific user. And by default, a Docker container runs as root. So it's a combination of mistakes. First of all, a configuration mistake on my side that I didn't specify a specific user for my application. But then again, I'm using an outdated version of a base image that has problems. So now I can do whatever I want, do something with packages, for instance. Let's see what's in there. So you get me. I can do all sorts of things now because every time I put in a command, the process or the runtime will get called and will execute that terminal command that I'm giving him without touching the application. So you see, this is another phase we now have to look at to make sure that we're not getting harmed. We talked about code, open source, and containers. And then there's this last little part under the hood, which is your infrastructure as code. Think about it. Your Kubernetes files, or maybe you're using Terraform. You basically use Kubernetes to orchestrate whatever you want to do with your different containers. If you're doing it wrong, you might give some nodes elevated privileges, and that might end up in a problem that it's, I don't know, outward facing while you're not wanting that. I don't have a demo of that, and we're out of time almost, but the point is where all of this is nowadays part of your repository. It's not only your code anymore. Your dependencies are stored in your manifest file, Maven, Gradle, SBT, whatever you're using. Containers, there is something like a Docker file or any other container or thing you're using. Infrastructure as code, again, it's code. It's part of that repository that you and your team need to take care of. And we're responsible for the whole shebang and not just the 20% code on the top. So what is the solution? Solution is 3 ways. Culture, I'm not sure what I did there. There it is. Culture, process, and tooling. Now let's go back to the first one. Culture. Again, think about your neighbors, the other folks you work with. We all have different KPIs. As a developer, I want to build things, make sure that it works, preferably use new cool frameworks, etc., etc. Operations folks, core operations folks, they think about, hey, how is it easily deployable? What happens if we go down? Is it auto-scalable? And do they call me at 3 in the morning if something goes wrong? Security folks, they have one KPI, not getting breached. Well, probably a bit more, but you get my point. If I am just cowboying around and just doing things and making a solution but not checking if it's safe, it doesn't help them and they might push back. Think about it the other way around. What does a manager think about? Upper level manager. Probably deliverables or making money in the end, right? You need to get that feature out today. You probably have heard that. If that's happening all day, all week, all year, you end up with a ton of technical debt. And at some point, you cannot innovate anymore. We all know that. But that is pretty much the same as we need to think about security. Because if we're not doing it, they are just like cleaning up our crap. So basically, we need to play along. We need to think in each other's mindset. We are one team. So that is the culture part. Then the process. As a security engineer, for instance, don't put in more process or new process. You have to tick all these boxes before you can go to production. Or you need to satisfy this tool, and I'm specifically saying it like that because that is what's happening. No, if you're using tooling, pick the tooling that fits your process. So not the other way around. If I love to work from an IDE like IntelliJ or whatever, and there's a plugin available, make sure that it's available to the folks. Command line tools on your local machine. Maybe a CI system. It's not just the capabilities of the tool, but how can I use it? Maybe automate a few things. But depending on the context, you can take bits and pieces and use it. At Snyk, we can help you with that. Snyk Code, I showed you some capabilities. Snyk Open Source, we can scan your open source libraries to see if there are any issues. Just to give you an example, I might have something here. In this project, for instance, the security workshop I showed you, we see that in the POM file, and I scanned this on my Git repositories, we see that there is the log4j problem. There is the commons collections problem. So this is already out in the open. And basically fixing these vulnerabilities gives me a pull request to my Git repository. But maybe I'm not working with GitHub and I want to fix it on my local machine. Well, I showed you over here the container problem. And if I'm right, yes, I scanned this on my local machine with, in this case, the Snyk CLI to see what's happening. And again, it says here, I'm using Tomcat 8521. And this is just on my local machine again, 8521, which was vulnerable. But if I update to 8.5.76, I would get from 694 vulnerabilities from the base image to 65. And that would also solve that JSP problem I showed you earlier. But I'm using it not, these are the different capabilities, it scans containers, but I can use it on my local machine as well. Same for the code, same for the open source problems. It's not just that, it's where you can use it, where you want to use it. So doing this, the Snyk open source, Snyk container to show you the base images or binaries that you pull in. And of course, Snyk infrastructure as code to see if you're making, well, maybe silly or not so silly configuration issues. Anyway, it's not just what you use, it's when you use it. On your local machine, either in your IDE or as a CLI tool, or maybe part of your build system, you want to connect your Git repository to it, because probably your code lives there for a while. And what is good tomorrow, it may not be good, or what's good today may not be good tomorrow. And you want to, some of these cases, you want to intervene like right away. Think about the log4j thing. You might have a CI pipeline or a CI/CD system connected over there, and maybe you want to block it, maybe not. That's all up to you. Maybe you're comfortable with a certain level of vulnerabilities. I'm not saying you have to go to zero. That depends on your situation. I cannot look into that. But when you go to production, you still have to look at that. You still have to look at what is in production, because at that point, it's static. With Snyk Monitor, I can basically get an image of your dependency tree and your Docker base image. And if I scan that over time, say on a daily basis, and I know when there are new vulnerabilities disclosed, I can ping you right away. So if it lives in production for a week, a month, a year, you want to know what the current status is. And with that information, you can make a choice if you need to intervene right away, or you can say, I'm ignoring it for now because it's not an actual issue for us. But you need to have the right information. If you don't have that, then it's just guessing and hoping. You can pray and maybe that works, but I'm not sure. Anyway, a lot of people say we need to shift left. And shift left means left in this thing. Start on the machine of the developer. But there is no left in a continuous process. That means shifting left and only doing it on the developer side doesn't work. Do it in every stage, or as much as possible. Catch it early, catch it often. Just like, for instance, your unit test. You're not running it only on your local machine. You're also running it in your CI pipeline. And maybe you use a smoke test for the stuff that is in production. Think about it in the same way with security. For either your code, your dependencies, your containers, and your infrastructure as code. This is all I had to say. And, well, it's almost top of the hour. So thank you so much, at least, for listening at me. Thanks.
Thank you so much, Brian. That was really interesting, absolutely fascinating. Thank you. Just quickly, does anybody have any questions for Brian before we go?
If you're the same as me and you come up with questions afterwards, like tonight or something, feel free to ping me on Twitter. I will put my Twitter handle right here. My DMs are open, so... Oh, that's the wrong one. I misspelled my own name. Wow.
It's okay. It happens to the best of us.
So if you come up with questions later on and like, hey, how did you do that? Or can we do something else? Or does this help? I might be able to answer you or refer you to other folks that can help you better. So feel free to DM me if you have any more questions afterwards, or you're watching this video afterwards.
Fab. Thank you so much, Brian. On behalf of RecWorks, it just leaves me to say thank you so much to everybody who's come today, and thank you to Brian for speaking to us, and we're looking forward to our future events with you guys at Snyk as well. So
Absolutely.
yeah, thanks very much. Have a great afternoon.
All right.
Take
Bye-bye.
care.
Cheers.
Bye.